The formation of planets is a fascinating process that begins in the vast clouds of gas and dust found in space, known as molecular clouds or nebulae. These clouds are the birthplaces of stars and planets, setting the stage for the creation of entire solar systems. Let's explore how planets come into being. 1. The nebula and the birth of a star. Planet formation starts within a nebula, a massive cloud of gas and dust. Over time, parts of the nebula begin to collapse under their own gravity, often triggered by events like nearby supernova explosions. As the cloud collapses, it starts to spin, forming a flattened disk with a dense center. This center continues to accumulate mass, eventually igniting nuclear fusion and giving birth to a star. The remaining material in the disk, called the protoplanetary disk, is where planets begin to form. 2. Accretion, building planetary seeds. As the protoplanetary disk spins around the newborn star, particles within the disk start to collide and stick together, forming larger and larger clumps of matter. This process is known as accretion. Over time, these clumps grow into planet cells, small, solid objects that can range from a few meters to hundreds of kilometers in diameter. These planetesimals are the building blocks of planets. 3. The formation of protoplanets. Once planetesimals reach a certain size, their gravity becomes strong enough to attract more material from the surrounding disk. This leads to further collisions and merging of planetesimals, forming even larger bodies called protoplanets. These protoplanets continue to grow by attracting more gas, dust, and smaller planetesimals, gradually shaping into the planets we recognize today. 4. Differentiation and core formation. As protoplanets grow and accumulate more material, they begin to heat up due to the energy from collisions and the decay of radioactive elements. This heating causes the internal structure of the protoplanet to differentiate, with heavier materials, like metals, sinking to form a dense core, while lighter materials like silicates rise to form the mantle and crust. This differentiation is a key step in the development of a planet's internal layers. 5. The role of gravity and orbits. As the protoplanets continue to grow, their gravity influences the orbits of other nearby objects, clearing out their orbital path. This process is known as clearing the neighborhood. The protoplanets either capture smaller bodies, incorporate them into their mass, or eject them from the disk. Eventually, the protoplanets settle into stable orbits around the star, completing their formation. 6. The divergence of terrestrial and gas giant planets. The location within the protoplanetary disk plays a crucial role in determining the type of planet that forms. Closer to the star, where temperatures are higher, rocky planets, terrestrial planets, like Earth, Mars, Venus, and Mercury formed from metal and silicate materials. Further out in the colder regions of the disk, gas giants like Jupiter and Saturn, as well as ice giants like Uranus and Neptune form. These planets are able to accumulate large amounts of gas and ices, making them much larger than terrestrial planets. 7. Late-stage bombardment. After the planets have largely formed, the solar system undergoes a period known as the late heavy bombardment. During this time, remaining planetesimals and debris collide with the newly formed planets and moons, leaving craters and sometimes contributing additional material. This phase is believed to have played a significant role in shaping the surfaces of the inner planets and moons. 8. The stabilization of the planetary system. Eventually, the solar system stabilizes as most of the remaining debris is either captured by planets, ejected into space, or falls into the star. The planets settle into their final orbits, and the protoplanetary disk clears out, leaving behind a relatively stable planetary system like the one we observe today in our solar system. In summary, planet formation is a complex process that begins with the collapse of a nebula, leading to the formation of a star and a surrounding protoplanetary disk. Through accretion and collisions, planetesimals grow into protoplanets, which differentiate into layered bodies and settle into stable orbits. Depending on their location within the disk, these bodies evolve into either terrestrial or giant planets, ultimately creating a balanced and dynamic planetary system.